I'm Brien Posey, and today I want to talk to you a little bit about keeping Hyper-V healthy. For those of you who don't know me, I want to give you just a little bit of information about my background. I'm a freelance technical writer, have been for quite some time, and I'm an 11-time Microsoft MVP. Before I went freelance, I worked as a CIO for a nationwide chain of hospitals and healthcare facilities, and I served as a network engineer for the United States Department of Defense at Fort Knox. Before that, I also worked as a network administrator for some of the largest insurance companies in America. So that's just a little bit about my background. So as I said before, my subject today is keeping Hyper-V healthy. Now, Hyper-V is a complex application, and like any complex application, there are a lot of things that you can do, or in some cases should be doing, to keep Hyper-V healthy. But for this particular presentation, I'm going to focus on two things specifically. First, I'm going to be talking about resource monitoring, or resource metering, as Microsoft likes to call it. The other thing that I'm going to be talking about is cluster-aware updating. Both of these are commonly misunderstood topics, so those are the areas that I'm going to be focusing on. So I want to start out by talking about resource metering. Now, resource metering is exactly what it sounds like. It's keeping an eye on the resources, the physical hardware resources that are being consumed by your virtual machines. Now, obviously, resource metering is helpful for things like capacity planning and for making sure that you're not overloading your host. But there's a little bit more to it than that, because resource metering can also be very helpful for your applications. You know, a lot of applications are no longer confined to a single physical server or even to a single virtual server. Things like Exchange or SharePoint are known as distributed applications. In other words, there might be multiple application roles that reside on different virtual machines. So this one application could be consuming a wide variety of resources because there are so many different virtual machines in play at any given time. And resource metering can actually be set up to keep track of application-level resource consumption just by looking at the virtual machines that are in use by that application. Now, to be perfectly clear, there's no way in Hyper-V of saying, show me the resources that all of my Exchange servers are using. You can't do it at that level. But what you can do is if you know the names of your Exchange servers, then you can set up resource metering to monitor those specific servers and thereby see what resources are being consumed. I'll show you how that works as we go along. Now, another way that resource metering can be helpful is through the use of chargebacks. A lot of organizations are adopting a private cloud model, and they're allowing individual departments to create virtual machines at will, but then they implement chargebacks to charge the individual departments for the resources that they use. But in order to do that, you have to keep track of what resources are actually being used, and that's where resource metering comes into play. Now, before I show you how resource metering works, I need to point out that, unfortunately, there's no way to do resource metering through the GUI. You're going to have to do this through PowerShell. So I'm going to show you a lot of PowerShell code today, and I promise I'm going to make this as painless as possible. I'm not going to try to make anybody's head hurt or anything, but we are going to have to delve into the shell to make this work. So before I actually start showing you code, I want to talk about what you can actually accomplish through resource metering. Now, Microsoft allows us to do resource metering for a variety of different resources. You can see on the slide a list of some of the resources that we can meter. For starters, we can look at the average CPU usage. We can look at average physical memory usage along with minimum and maximum memory usage. We can also look at the maximum amount of disk space that's consumed by a virtual machine. Now, unfortunately, that's the only disk metering option that Microsoft provides at this time. So we don't have a way of looking at disk I/O as a part of resource metering. We can only look at storage consumption. And in addition, we can also look at network traffic, both inbound and outbound, and we can look at that on a per virtual network adapter basis. Now, before I move on, I do need to point out that all of these things that we can meter, these are done on a per virtual machine basis. So another thing that I want to point out about resource metering is that Microsoft is making a few changes in Windows Server 2012 R2. Now, the actual items that you're going to be able to meter haven't changed. Those are still the same, and all of the PowerShell code that I'm going to be showing you as we go along, that hasn't changed either. But what has changed is that Microsoft has added some port ACLs. And what this does is it allows you to differentiate between internal and external network traffic. This is really handy if you're doing chargebacks, because if a user is consuming internal network bandwidth, well, there's not really a cost associated with that, so you may not want to bill them for that. But if they're consuming WAN bandwidth or internet bandwidth or something like that, then there may very well be a cost, and that might be something that you want to include in the chargebacks. And these port ACLs make it possible to do that. Now, resource metering is going to have to be enabled before you can use it. It's not something that's enabled by default. And the reason for that is that resource metering does consume a degree of system resources, so Microsoft leaves it turned off unless you use it. So let me show you how to enable it. So what we've got here is our first block of PowerShell code, and here we're enabling resource metering at the host level. So you'll see the commandlet on the screen says get-vm, and then we've got the computer name parameter, a computer name, the pipe symbol, and then another commandlet, enable VM resource metering. Let me explain how this works a little bit. Even though what we're doing is host level enabling of resource metering, we're not actually enabling it at the host, because, as I said before, resource metering is a per virtual machine level operation. So even though the slide says per host metering, and we are enabling metering for all of the virtual machines in the host, we are actually enabling it for the virtual machines themselves, not specifically for the host. So if you take a look at the code, you'll notice it starts out with get-vm and then dash computer name, and then on this slide, lab1. So what this is doing is this is retrieving a list of all of the virtual machines that are running on a host called lab1, and then we're enabling resource metering for those virtual machines. Now, the reason why this is so important is because, as we all know, the collection of virtual machines that are running on a host is rarely static. You might create new virtual machines, you might delete virtual machines, you could have virtual machines live migrated in and out of that host. So the collection of virtual machines tends to change over time. And those changes don't impact the resource metering, because remember, resource metering gets enabled on a per virtual machine basis. So if you enable resource metering for all of the virtual machines that are on a host, and then you add a new virtual machine or you live migrate a new virtual machine, well, resource metering isn't going to be turned on for that virtual machine. You're going to have to go in and turn it on manually. So that's something very important to keep in mind. So what if you just wanted to enable resource metering for a specific virtual machine? Well, that's really easy to do as well. On this slide, you can see that we've got the commandlet get-vm, just like we had before, but this time, instead of specifying the computer name parameter and the name of a host server, we're just providing the name of an individual virtual machine, in this case VM2. And then we're piping that into the enable VM resource metering commandlet. So very, very simple. Now, the one thing that you need to understand about the resource metering process is that the resource collection doesn't happen in real time. You're not going to get real-time reporting off of Hyper-V resource metering. Instead, by default, resource metering data is collected hourly, but you can change that. As a matter of fact, on this slide, I show you how to change it. If you want to change the collection interval, what you do is use the set-vm host commandlet, and then you specify the name of the host server using the computer name parameter, and then you add the resource metering save interval parameter, and then your save frequency. In this case, I've got it set to 1 minute. Now, a few things that I need to point out about this. Even though resource metering is enabled on a per virtual machine basis, not a per host basis, the collection interval is set on a per host basis. You can't use different collection intervals on different virtual machines. This is a host-wide operation. The other thing that I need to point out is that Microsoft doesn't recommend that you do resource metering data collection any more frequently than once a minute. Even going once a minute is kind of pushing it because, as I said before, you are consuming some resources with the data collection process. So I don't recommend going any more frequently than this. So as you go along, you collect all this wonderful data for your virtual machines. How do you view that data? Well, it's pretty simple if you just want to get a basic view of the data. You can see right here we've got get-vm, and I specify the name of a virtual machine, in this case VM2, and then we pipe that into the commandlet measure-vm. Measure-vm is the commandlet that displays all of the metering data. And right below the command string, you can see that we have a number of pieces of information that are displayed. You can see the virtual machine name, the average CPU usage, average RAM, maximum RAM, minimum RAM, and so on. So it's very, very simple to display the metering data. Now, I promised you that I wasn't going to make your head hurt and not get overly complicated with PowerShell, but I do need to dive just a little bit deeper in this because in the real world, things are rarely quite as simple as what's shown on the screen. Yes, if you need to look at an individual virtual machine, you can use this commandlet, and it works exactly as you see right here. But as I said in the very beginning, oftentimes resource metering involves looking at multiple virtual machines because a lot of times an application that you're trying to meter will span multiple virtual machines. So you have to know how to deal with large numbers of virtual machines. So I'm going to show you some techniques for that. What if you wanted to look at the resource metering data for all of the virtual machines on a specific host? Well, the command that you would use to do that is a variation of what I showed you a minute ago. We start with get-vm just as we did before, but this time rather than specifying a virtual machine name, what I'm doing is I'm adding in the computer name parameter and the name of a host server, and then we're piping that into the measure-vm commandlet, which is the same commandlet we used before. So this time we see metering data for all of the virtual machines on the host for which metering has been enabled. Now, the one thing that I need to point out about this is there's only about 20 virtual machines that are displayed on this slide. So it's pretty easy to go through and take a look at all the metering data for those virtual machines. But Hyper-V is very, very scalable. So what if instead of having 20 virtual machines, what if I had 2,000 virtual machines or 200 virtual machines or something like that? Well, in those types of cases, you probably wouldn't want to look at the metering data for all of your virtual machines on screen all at the same time. That would be overwhelming. So what you would do instead is you would use a variety of filtering techniques to narrow down the list to get the information that you really need. So this is where things get just a little bit more complicated, but it's still not terrible. And I'm going to show you a few techniques that you can use. And again, this is all just basic PowerShell stuff that you can apply to narrowing down the results list. Before I show you that, I do want to show you one other trick that's going to come in handy as you do build custom data metering reports. What I've got here is a command get-vm, just like what we've been using. I'm piping that into measure-vm, and then I pipe that into another PowerShell commandlet, select object, and I've got an asterisk. So what this does is this collects all of the VMs on a host. It pipes that into the measure-vm commandlet that we've been using all along, and then it's telling PowerShell that we want to look at all of the attributes of measure-vm. That's what the asterisk does. So you can see here we've got a list of all of these different attributes. We've got average CPU, average RAM, minimum RAM, maximum RAM, total disk, and the list goes on. The reason why this is important is because if you want to start building custom reports for your resource metering data, you're probably going to need the names of some of these attributes. And this screen right here shows you what those names are. So for example, if you want to include the average CPU usage in your report, well, you're going to need to know that attribute name. In this case, you can see right here on the slide that it's AVG CPU. So you'll need to know that spelling for that attribute name, and this is exactly how you get it. So let's continue on. Let me show you how this works. Let's suppose, for example, that you wanted to create a custom report and you wanted to include the average RAM, maximum RAM, and minimum RAM. Well, what you would do is you would start with get-vm, just as we have in all of the commands that we've looked at, and then we pipe that into measure-vm so that we can get the resource metering data. But then we pipe that into select object, and here's where we get to specify the objects that we want to include in the report. So in this case, we're including VM name, that's the virtual machine name, average RAM, maximum RAM, and minimum RAM. And you can see right below that command line that we have a custom report that shows all of our virtual machines and only the data fields that we've specified. So that's just one way that you can begin narrowing down the information that's shown to get exactly what you want. Now, that's not the only thing that we can do. We can also sort the results. Because remember, as I said earlier, you may run into a situation where instead of having 20 virtual machines, you might have 200 or something. And if there's a particular piece of information that you're looking for, it's going to be a lot easier to find that information among the list if you can narrow things down. For example, on this particular slide, what we're doing is we're sorting based on average memory consumption. You know, that's important. Memory is often the limiting factor with regard to virtual machines and how many virtual machines a host can accommodate. So what we've done here is I've created a report showing or where all of our resource consumption data is sorted by memory consumption. Let me show you how this works. We start out with the get-vm commandlet, and we pipe that into measure VM, and then we're using sort-object. So this tells PowerShell that we want to sort the output. Now, the next thing that we've got is the property switch. That tells PowerShell which of our fields we want to sort by. And I specify average RAM as the sort field, and then I add descending so that PowerShell knows what order to sort the data in. And then we provide the pipe symbol, and then from there I use select object and specify the fields that I want to include in the report, just as what we did before. So the result is a list sorted by average average memory consumption. And you can see in the report that a virtual machine called lab15-exchange is at the top of the list, and it's consuming just short of 8 gigs of memory, and that every machine below that uses less and less memory. So that's how we can sort the results. Now, what if we want to narrow things down a little bit? What if we've got a huge number of virtual machines and we're only interested in the ones that are consuming the absolute most resources? Well, there's a way of doing that too. If you take a look at the commandlet that we've got here, we start with get-vm, pipe that into measure-vm, just as we have before, and we use sort-object, -property, average memory, just as we did in the previous slide. We're doing a descending sort once again, and we pipe the output into select object. All of this is exactly like what we did on the previous slide. Now here's where things get a little bit different. You'll notice that we've got a property called -first, and then I specify 3. So what this is doing is we're sorting the output by average memory consumption, but we're telling PowerShell to only display the first 3 results. So that way, instead of having a huge list of all of our virtual machines, we're only seeing the 3 virtual machines that are consuming the most memory on average. So this can be very, very helpful if you have a large list of virtual machines and you need to narrow that list down according to a certain value. Now, those certainly aren't the only filtering options that we've got. We've got some other options. Another thing that you might want to do is display your results based on some threshold value. For example, if I can flip back a couple of slides, you'll notice on this slide that the average RAM column, we have a lot of virtual machines that aren't turned on, so those virtual machines have an average RAM value of 0. We really only have 4 virtual machines that are consuming any RAM at all in this particular slide. So what if we wanted to hide all of the 0 values and only show real data? Well, we've got a way that we can do that. We can do that using PowerShell operators. So what I've got here on this command is get-vm, and we pipe that into measure VM. But then what we're doing here is we're using where and then minimum RAM, and then you see -GT. That's a way of telling PowerShell greater than. We could do -LT less than, -EQ equals to, and then we provide a value. In this case, I'm providing a value of 0. So what this command does is this is showing all of our virtual machines where the minimum amount of RAM is greater than 0. So essentially, this is a way of showing just the virtual machines that are powered on at the moment. But really, we could use any resource metering attribute, and we could use any threshold value we wanted. So this is a great way to look for very specific data within your resource metering. So as you can see, there are a million different ways that you can filter your data. I've only shown you a few. PowerShell is very, very flexible, and your imagination and your PowerShell skills are really the only limit to what you can do. But having said that, viewing all of your data on screen isn't always practical. Sometimes you need to be able to export that data so that you can view it later or so that you can do other things with it. And you've got a few options for doing that. One option is to export the data to a CSV file. Now, for anybody who's not familiar with CSV, a CSV file is a comma-separated value file. And a CSV file can be read in directly by Microsoft Excel. So you can pull this CSV file into Excel, and you can build graphs off of the data, you can sort the data, you can perform mathematical operations on the data. You have tremendous potential for what you can do with it. But you have to get that data into a CSV file before you can do all that. So here's how you can go about doing that. Here I have a PowerShell command. We start with get-vm, pipe that into measure-vm, just as we have been doing all along on these slides. But then, once we do that, we add a pipe symbol, and then we use the commandlet export-csv. That's the commandlet that's going to export all of our data into a CSV file. And then we simply provide a file name. And that's really all it takes to dump all of that data into a CSV. Now, another thing that we can do is we can build an HTML-based report. So that way you can view your data as a web page, or you can have it for offline viewing, however you want to handle that. Now, building an HTML report works a little bit differently than building a CSV file. You'll notice right off the bat that the command is a little bit more complicated. If I can flip back to the previous slide, I want to show you something. You'll notice that with this slide, we just had 3 PowerShell commandlets piped together. We had get-vm, measure-vm, and export-csv. That was it. That was the whole command. Now, when we're building an HTML file, we start with get-vm and measure-vm, just as we did when we were creating a CSV file. But we also have to add in select object and add the objects that we want to include in our HTML file. I don't know why Microsoft chose to do things this way, but this absolutely will not work right if you don't include the objects that you want to, or excuse me, if you don't specify the objects that you want to include in that HTML file. So here we have select object. We've got the attributes that we want to include. And then after I specify those attributes, we've got a pipe symbol, and then convert to HTML. That's the command that's actually going to build the HTML file. And then a pipe symbol, and then another command, out file. And then after out file, that's when we specify the path and file name that we want to use for our HTML file. Now down at the bottom, you'll see another commandlet, invoke expression. This isn't a commandlet that's required by any means, but what this is it's a way of launching the HTML file from PowerShell. If you enter this commandlet, then what PowerShell is going to do is it's going to open Internet Explorer and then open the file that you just created so that you can view it immediately. It just keeps you from having to go into File Manager and manually open the file in Internet Explorer. Kind of an automated way of doing things. Now, one thing about building an HTML file in this way is the file is going to be very, very bland. It's all going to be black and white. There's no formatting or anything. It's basically just raw data displayed on a screen. But you can make things a little bit more exciting. Now, in the interest of time, I'm not going to try to go through everything on this slide. I put this here more for illustration purposes. So you'll notice in the first line we've got $A equals, and then in quotation marks we've got the style attribute. So what $A is that's a way of declaring a variable in PowerShell. Now, every subsequent line starts with $A equals $A plus. This is simply a way of adding more and more elements to a variable. We don't have to do things this way. We could add all of the HTML code to a variable up front. This was only done this way just for readability. But if you look at the HTML code that we're adding to this variable, you can see that we're setting up a style section, we're specifying a body color, we're building a table. So we've got all these different things that we're doing, and then we're closing the style section. Then down at the very bottom, we've got our get-vm, measure-vm. We're selecting the objects to include in the HTML file. We've got convert to HTML. But then here's where things get a little bit interesting. Right after convert to HTML, we've got a -head parameter. And we're specifying $A after that. So all of this HTML code that we've added to the $A variable is going to be inserted right there. So then after our $A variable, we're inserting body code. And in quotation marks, we've got an H2 header. We've got performance data. We're closing the H2 header. And then only then do we do out file, and then we're specifying the name of the HTML file that we want to create. Now, I don't expect you to remember all that. You can certainly look all this up, or you can create your own HTML code, whatever you want to do. I'm only putting all of this on this slide just to illustrate the fact that you can get a lot more creative with regard to formatting when you build an HTML file from PowerShell. You're not limited to just the plain black and white HTML file that PowerShell gives you by default. So what does all of this get us? Well, on the next slide, you can see some samples that were taken from TechNet. Now, this isn't resource metering data, but this is very similar to what you would get. So the screen on the left shows you a default PowerShell generated HTML report. As you can see, it's just black and white. It's very plain and dull. The report on the right is based on the HTML code that I used on the previous slide. All of that code was taken directly from TechNet. The source is included on the slide, so that way you can go back and get that on your own if you want to try this later on. So with that said, I want to shift gears and I want to talk about cluster-aware updating. Now, prior to Windows Server 2012, patching a failover cluster was a lot of work, because to do that, you had to basically live migrate all of the virtual machines off of a cluster, or excuse me, off of a cluster node, and then you had to put that node in maintenance mode, do your patching, take the cluster node out of maintenance mode, then move on to the next node, live migrate all of the virtual machines off of that one, put it in maintenance mode, do the patching, and so on and so forth. It was a big job because, you know, nobody really knows what to expect come Patch Tuesday. Microsoft might release one patch, they might release a dozen patches. So you've got all of this patchwork that has to be done, and it was very, very tedious to do it in a clustered environment. Now, if you stop and think about it, not every organization uses one cluster. A lot of organizations have multiple clusters. And the bigger the cluster, the more work. You know, in Windows Server 2012, we can build Hyper-V clusters with up to 63 nodes. So can you imagine manually patching a 63-node cluster? That would be a tremendous amount of work. So in Windows 2012, Microsoft decided that cluster patching was too much work, so they decided to automate the process using something called cluster-aware updating. So I want to show you how that works. Now, cluster-aware updating is installed as a part of the failover clustering feature. So what I've got here is I've got the server manager and the roles and features wizard, and I've worked through the wizard partially until I get to the features screen. And what we would do is select the failover clustering feature. Now, one thing that I want to point out is that you don't actually have to do this on a cluster node. Yes, the failover clustering feature has to be installed on all of your clustering nodes, but if you want to manage cluster-aware updating from outside of the cluster, then you can install this feature on just about any machine and use that as a management server. So when you go to install the failover clustering feature, you'll see this message saying that there are additional features that have to be installed. So you would click on the Add Feature button to make that happen. And then we see a confirmation screen. We would click Install, and the installation process completes, and we're ready to go. Now, the only thing that this accomplishes is installing the failover clustering feature. We're still not quite ready for cluster-aware updating. We have a little bit of configuration work that has to happen first. So let me show you how that works. What you see on this slide is an excerpt from the Server Manager. I've selected the Tools menu, and you'll notice that now that the failover clustering feature is installed, the very first menu option is cluster-aware updating. So we would select that, and then that is going to cause Windows to display the cluster-aware updating screen. So what we've got here in the upper left portion of the screen is the name of our cluster, and then below that you see the nodes that are in the cluster. Now off to the right in this dialog box, we've got a number of menu options. And you can see that the arrow is pointing to an option, Configure Cluster Self-Updating Options. So that's what we would want to click on in order to configure cluster-aware updating. So when we do that, we would see Windows would launch the Configure Self-Updating Options wizard, and in typical Microsoft fashion, there would be a welcome screen. You would just click Next to get rid of that welcome screen, and then that brings you to the screen that we see right here. Now, there are a couple of things to look at right here. The first thing is the area that's circled. you can see it says, warning, this failover cluster is not configured with the cluster aware updating CAU clustered role. So what this is saying is that cluster aware updating is actually a role that has to be deployed within your cluster. This is a clustered role. So that has to be installed. There's also a checkbox that needs to be selected. It's called Add the CAU cluster role with self-updating mode enabled to this cluster. Now, this checkbox is selected by default, but you do need to stop and make sure that it is selected because cluster aware updating won't work if you don't select that. So then the next screen that you see after you click Next allows you to set a schedule for cluster aware updating. So as you can see, you can set the frequency of self-updating. You can set it for daily, weekly, monthly, whatever you want. The one comment that I would make about this particular slide is that you should avoid doing any kind of updating during peak business hours because, as I mentioned before, when you update a cluster, all of the virtual machines on one cluster node at a time have to be live migrated off of that node. And there is a degree of overhead that occurs as a result of all of those live migrations. So while the cluster is being updated, you're essentially operating at reduced capacity. So I would schedule this to run, late at night or on a weekend or at some time when it won't be overly disruptive. Yes, all of your virtual machines will remain online and they'll continue to run, but being that you're essentially taking one cluster node at a time offline, there is going to be a bit of a reduced capacity. So what about some additional options? What we've got on this screen is a checkbox that you can use to install recommended updates the same way that you receive important updates. Whether or not you choose this option is entirely up to you. Generally, I would recommend going ahead and installing recommended updates, but you probably want to set this up in a lab environment so that you can test those updates first before you just go ahead and deploy them onto your production cluster. So once you work through all of the screens on the wizard, you should see a screen like this indicating that the configuration was successful. Once you get to that point, you can click Close. And then we're brought back to the main cluster aware updating screen. Now, once you get back to this point, it's a good idea to see what updates are available. And you can do that by clicking on the Preview Updates for this cluster option, which the arrow is pointing to. So when you get to the Preview Updates screen for the first time, the list is going to be completely empty, like what you see here. To fix that, you're going to need to click the Generate Update Preview List button, which the arrow is pointing to. So when we click that, Windows is going to take a little bit of time. It's going to generate a list of updates, which you can see right here. This is going to tell you what updates are available. So once you've gathered that list and you've had a chance to review what updates are available, you would click Close. And that's going to bring you once again back to this screen. So let's say that now you want to go ahead and apply those updates. To do that, you would click Apply Updates to this cluster. And then Windows is going to launch the Cluster Aware Updating Wizard. And you'll see a couple of things on the screen that I want to point out. The first thing is the arrow in the upper left. You can see it says Command to Run. And just to the right of that, we actually see a PowerShell command. So the reason I wanted to point this out is just to show you that you don't have to use the GUI to apply these updates. You can actually do this through PowerShell if you prefer. Now, if you do prefer to use the GUI, then all you would have to do at this point is click the Update button, which the lower right arrow is pointing to. So once the update completes, you should see a success screen like this one, and you would click Close, and the update's complete. But as you can see on the screen right here, there isn't really a good indication that everything was successful or a good way of seeing what updates were actually applied. So you're probably going to want to create a report showing the status of the updates. And the Cluster Aware Updating dialog box actually makes this pretty easy to do. You'll notice that the arrow on the screen is pointing to an option, Generate Report on Past Updating Runs. So if we click this, then it gives us an option to build a report. So what we can do here is we can set the start date and the end date for the report, and then click Generate Report. So here's what the report looks like. Here you can see in the upper left we have a run date column, and we can click on the run date, And we have a corresponding run ID. You can see how many updates were applied on a particular date and the status of those updates. So you can see the one on the top failed, and then we have two beneath it that partially failed. Well, in a situation like that, we would probably want to know what partial failure means. Generally, that means that there were some updates that couldn't be applied. Well, how do you know which updates were applied and which weren't? If you look at the column on the right, it shows the list of updates that were applied as a part of that particular run ID. And we can see the status of each one of those individual updates. So we can go through this list and determine which updates were applied and which ones weren't, and get a sense of the overall health of our Hyper-V cluster. Now, this is a lot of data to take in, and the interface that's shown here probably isn't the best for really getting a feel for what's going on with regard to your updates. Fortunately, Microsoft gives us a way of creating an HTML-based report. If you want to export this data to an HTML-based report, all you have to do is select the run date that you're interested in, and then click on the Export Report button, which is shown at the lower right-hand corner of the screen. When you do that, you're going to receive a report similar to this one. This is just an excerpt from an HTML-based report, and you can see that it's a whole lot easier to read than what you saw on screen a second ago. More importantly, however, Internet Explorer has a search option. If you hit the Alt key, there's a menu that pops up, and one of the options that's featured on the menu is Search This Page. So if you're interested in knowing which updates failed to install, you could do a search on the word failed, and that would point out all the updates that failed to install. Another thing that you could do is if you were interested in knowing the status of a specific update, then you could do a search on the ID of that particular update, and it would take you directly to the information for that update. So exporting to HTML gives you search capabilities, and it also gives you an easy way of saving the data so that you can go back and look at it at a later time. So that's going to about do it for me. If anybody wants to contact me, my email address is brian@brianposey.com.